You step outside just after noon. The air feels solid, almost thick enough to push against. Within minutes, your skin is burning, your throat is dry, and every surface you touch, stone, metal, even the ground itself, feels like it could scald you. Now imagine there is no air conditioner, no electric fan humming in the corner, no cold water waiting in a refrigerator, no shaded car to escape into. This is not a hypothetical. For thousands of people living across the Iranian plateau more than 2,000 years ago, this was simply Tuesday. So how did people in ancient Persia actually survive temperatures that regularly climbed past 40 degrees Celsius, sometimes even higher, for months at a stretch? The answer is not what most people expect. It was not luck, and it was not simple endurance. It was a civilization-wide system of engineering, architecture, timing, and social rhythm, built up over centuries and refined until surviving the heat became something closer to an art form than a daily struggle. To understand this, you first have to understand where these people actually lived. The heartland of the Achaemenid Persian Empire, the great Persian state that rose under Cyrus the Great in the 6th century BCE and expanded under rulers like Darius and Xerxes, sat across a landscape of extremes. Much of the Iranian plateau is arid or semi-arid. Summers are brutally hot and almost entirely dry. Winters can be surprisingly cold. Water is scarce, unevenly distributed, and often located far beneath the surface rather than sitting conveniently in rivers and lakes. If you wanted to build a city, a farm, or even a single household here, heat and water scarcity were not occasional problems. They were the defining conditions of daily life. The historian Pierre Briand, one of the leading modern scholars of the Achaemenid Empire, has argued that understanding Persian civilization requires understanding its relationship with the land itself, not just its kings and armies. And nowhere is that relationship clearer than in how ordinary Persians dealt with heat. The first and most important tool in this survival system was not a building at all, it was water, and more specifically, how Persians managed to move water across vast dry distances without losing it to evaporation. The solution was the Qanat, an underground channel that carried water by gravity from an aquifer at the base of a mountain or hillside, sometimes many kilometers away, directly to a village, city, or field. Because the channel ran underground, the water stayed cool and largely protected from evaporation, even as it crossed some of the driest terrain in the ancient world. Qanats were not a minor technical curiosity. They were a foundation of Persian civilization. Archaeological and textual evidence suggests that Qanat systems were already well established during the Achaemenid period, and later Achaemenid administrative practice even provided tax incentives to individuals who dug new Qanats, since a new water source could support new farmland and new settlements. Imagine the sheer physical effort involved. Workers dug vertical shafts at intervals along the planned route, sometimes descending tens of meters into the earth, then connected them with a gently sloping tunnel, all calculated without modern surveying equipment. A single qanat could take years, even generations, to complete, and once finished, it might supply water to a community for centuries. This is the detail most people never expect. Long before anyone had electricity, Persian engineers had already solved one of the hardest problems in desert survival, keeping water cool and available using nothing but gravity, geometry, and an intimate understanding of the landscape. Now picture what that water made possible. With a reliable qanat supplying a settlement, Persian builders could support something that seems almost impossible in a scorching desert environment: gardens. The Old Persian word paradida, meaning an enclosed park or garden, is the direct ancestor of the English word paradise. These gardens were not simply decorative, they were functional cooling systems. Shade from trees lowered surface temperature. Moving water, channeled through narrow stone or clay conduits, cooled the surrounding air as it evaporated. The combination of shade and water created microclimates that could feel dramatically cooler than the open desert just beyond the garden walls. The famous four-part garden design, later called the Chahar Bagh, divided the space into quadrants using intersecting water channels, often meeting at a central pool or pavilion. Whether or not every version of this design existed in exactly this form during the Achaemenid period specifically, the underlying principle, using architecture and water together to manufacture shade and coolness, is well attested in Persian building practice from this era onward. Wealthy households and royal complexes used these gardens both as symbols of status and as genuinely functional relief from the heat. But you did not need to be wealthy to benefit from Persian cooling ingenuity. Ordinary households used a different, more universal strategy: the layout of the home itself. Persian domestic architecture across many periods relied heavily on thick mud brick or stone walls, which have high thermal mass. During the day, these walls absorbed heat slowly, keeping interior spaces noticeably cooler than the blazing exterior. At night, as temperatures dropped, the walls released that stored heat gradually, helping prevent homes from becoming uncomfortably cold once the sun disappeared. Homes were also frequently built around a central courtyard, a design used widely across the ancient Near East and adapted specifically to hot, dry climates. The courtyard created a shaded, semi-enclosed outdoor space where family life could continue even during the hottest parts of the year. Walls surrounding the courtyard blocked direct sun for much of the day, while any plantings or a small water feature, if the household could manage one, added further cooling through evaporation. Rooms often opened onto this courtyard rather than directly onto the street, both for privacy and for climate control. Ceiling height mattered too. Because hot air rises, taller interior spaces allowed heat to collect above head height, leaving the lower, lived-in portion of the room noticeably cooler. Small, high-placed windows or vents allowed some of that hot air to escape while limiting the amount of direct sunlight and blowing dust entering the home. Here is where you have to be careful about what the evidence actually supports. Many popular accounts of ancient Persian cooling technology jump immediately to the Badgir, the iconic wind-catching tower seen rising above buildings in later Persian and Islamic-era Iranian cities. These tall, chimney-like structures catch moving air at height and funnel it downward into the building, creating a kind of passive air conditioning. They are visually spectacular, and they absolutely represent a brilliant piece of Persian engineering. However, the clearest, most extensively documented examples of Badgirs come from later periods, particularly the medieval and early modern eras, especially in cities like Yazd. Whether fully developed wind-catching towers of this specific type existed in exactly this form during the Achaemenid period is genuinely less certain, and historians are cautious about projecting later Persian architecture backward onto earlier centuries without direct evidence. What we can say with more confidence is that the underlying principle, using height, air movement, and building orientation to encourage natural airflow, was already present in Persian architectural thinking well before the more elaborate wind tower designs became widespread. The Badgir, in other words, was very likely a later refinement of ideas that Persian builders had already been experimenting with for a very long time. This is exactly the kind of distinction the evidence demands. A surprising historical detail is not made less interesting by being precise about when it emerges. If anything, it becomes more interesting because it shows a civilization improving its own solutions across centuries rather than inventing everything at once. There is one more piece of this puzzle that regularly surprises people: ice. Long before mechanical refrigeration existed anywhere on Earth, Persians were storing ice through the hottest months of the year in the middle of a desert. They did this using structures called yakchals, dome-shaped buildings made of a special heat-resistant mortar, often positioned to take advantage of natural wind flow and sometimes paired with qanat-fed water channels. During winter, water was allowed to freeze in shallow pools, sometimes assisted by the physics of radiative cooling on clear desert nights, which can drop surface temperatures below freezing even when the surrounding air is not. The resulting ice was then transported into the yakchal's deep underground storage chamber, insulated by thick walls and packed for use later in the year. Some form of this method appears to date back roughly 2,500 years, placing early versions of ice storage within or very close to the Achaemenid period itself, though the more architecturally elaborate freestanding yakchal domes most commonly pictured today are generally associated with later Persian periods. Even accounting for that uncertainty, the core practice, deliberately manufacturing and preserving ice in a desert environment using nothing but geometry, insulation, and an understanding of nighttime cooling, is a genuinely remarkable achievement, and one that predates almost every other known ice preservation technology in the ancient world. Beyond architecture and engineering, ordinary Persians also survived the heat the way most desert-adapted societies eventually learned to, by restructuring the rhythm of the entire day around it. Physical labor, farming, construction, transport of goods tended to be concentrated in the cooler hours, early morning and later afternoon into evening. The most brutal midday hours were reserved for rest, shade, and lighter indoor tasks. This was not laziness. It was a rational, learned adaptation to an environment that could genuinely injure or kill someone who ignored it. The Greek historian Herodotus, writing about Persian customs from an outsider's perspective, and therefore requiring some caution, nonetheless describes Persians as people deeply attentive to practical matters of daily conduct, an observation broadly consistent with a society whose entire schedule was shaped around environmental survival. Clothing played its part as well. Persian dress, as reconstructed from relief carvings at sites like Persepolis and from garment fragments and textile evidence recovered by archaeologists, generally favored loose, layered fabrics rather than tight-fitting garments. Loose fabric allows air to circulate against the skin, carrying sweat away from the body and cooling it through evaporation, the same basic principle behind modern moisture-wicking fabrics, just achieved through cut and fit rather than chemistry. Lighter-colored fabrics, when available and affordable, also reflected more sunlight than darker ones, reducing how much heat the body absorbed directly from clothing itself. Diet adapted too, though the evidence here comes mostly through inference from broader Near Eastern practices, combined with what we know of Persian agriculture. Fresh fruit, particularly water-rich options like melons and grapes when in season, along with dairy products such as yogurt, offered hydration and cooling relief in a landscape where clean drinking water could not always be guaranteed in unlimited quantities. None of this was accidental. It reflected generations of accumulated practical knowledge about how to keep a human body functioning in an unforgiving climate. Put all of these pieces together, and a different picture of daily Persian life starts to emerge, one far removed from the marble columns and gold-draped kings that usually dominate the popular imagination of ancient Persia. Surviving the heat was not a single invention, it was layered infrastructure. Underground water systems, moving cool water for kilometers, courtyard homes engineered to trap coolness and release stored heat gradually, gardens that manufactured their own microclimate, ice storage structures that defied the surrounding desert, clothing designed around airflow rather than appearance, and a daily schedule built entirely around avoiding the sun at its most dangerous. Matthew Stolper, a historian who has spent decades studying the Persepolis fortification tablets, the administrative records of the Achaemenid Empire, has noted how much of that documentation concerns exactly this kind of practical resource management, water allocation, labor scheduling, and provisioning, rather than the military campaigns that tend to dominate popular retellings of Persian history. The empire that conquered from the Aegean Sea to the Indus River was, underneath all of that, also an empire that had figured out, in extraordinary technical detail, how to keep ordinary people alive and functioning in one of the harshest climates on the planet. And this is where the ancient world quietly reaches forward and taps you on the shoulder. Every time you walk into an air-conditioned building on a scorching afternoon, you are relying on the same basic goal Persian engineers were chasing 3,000 years ago, manufacturing a livable microclimate inside an unlivable one. The difference is mostly the tools. They used underground channels, thick walls, shaded courtyards, moving water, and careful timing. You use compressors and refrigerants and a thermostat on the wall, but the underlying human problem and the underlying human ingenuity required to solve it has not actually changed all that much. Next time your air conditioner clicks on and cool air starts pouring into the room, it might be worth remembering that somewhere beneath an ancient Persian city, a channel of water dug more than 2,000 years ago is still, in a sense, doing the same job.